Hey everyone, welcome back to The Explainer. Today, we're jumping right into a rapid 90-second teardown of QStorm Investigator. This is a highly specialized evidence copilot, purpose-built for the SUST CSE Carnival Challenge to tackle those really sensitive digital finance complaints. Right off the bat, it brings up a really fascinating, kind of controversial question. Can an AI support copilot actually be too unpredictable? In those high-stakes hackathon judging environments, just slapping an LLM onto a problem might actually turn out to be your biggest liability. Okay, let's dive into this. Meet QStorm Investigator. At its absolute core, we're looking at a stateless Django Rust API. It's got a super clean surface, just a get/health endpoint to check readiness, and a post/analyze ticket endpoint to handle the actual investigation. The whole thing is deployed on an EC2 instance using Unicorn. Basically, it takes in a customer complaint along with their transaction history and crunches it all down into perfectly structured JSON. Next up, let's look at the AI prototype pivot. Now, what's really interesting about this slide is that this project actually started out as a hosted Gemini prototype. But as we all know, dealing with API key risks, network dependencies, latency, and worst of all, hallucinated enum values, well, that's just a recipe for disaster when you're facing hidden judge tests. So the team completely pivoted. They deliberately scrapped the AI for a deterministic rule engine. The result? Zero API risk, a totally standalone build, lightning-fast latency, exact control over those enum values, and 100% safe wording. Which brings us to the evidence matching logic. Let's walk chronologically through exactly how a single request flows through the system. Step 1, the complaint and history hit the API. 2, the text gets classified using these really clever English, Bangla, and Banglish patterns. 3, it scores the transaction evidence. 4, it produces a verdict and routes the case. And finally, step 5, it returns that sweet, structured JSON. And guys, I want to emphasize, this isn't just some basic text classifier. It actively investigates the case by cross-referencing the complaint against cold, hard transaction evidence. It looks at 4 strict criteria: the mention amount, finding a counterparty match, the expected transaction type, and the transaction status. So what does this all mean? Well, this scoring logic yields one of 3 absolute bulletproof outcomes. Either the complaint is consistent and perfectly matches the evidence, it's inconsistent and contradicts the data, or there's simply insufficient data to verify it. This exact setup absolutely guarantees the strict enum compliance that those hidden judging scripts demand. Moving on to critical safety guardrails. Because we're in digital finance, safety is literally everything. So the crucial point here is that Investigator is hard-coded with a zero-trust policy. It will never ask a customer for a PIN, an OTP, a password, a full card number, or a CVV. That is exactly the kind of thing an unpredictable LLM might accidentally slip up and ask for, right? Furthermore, it absolutely never confirms a refund, a reversal, an unblock, or an account recovery. Instead of making risky automated promises, any suspicious or high-value case is safely and immediately routed straight to a human review flag. It's a massive safety net. Let's move to our next point and see how this builds into a stateless and secure deployment. The deployment profile here is rock solid. We're talking Python and Django REST framework running on Unicorn on an EC2 instance. Django debug is turned off, allowed hosts are strictly set to the public IP, and, most importantly, there is 0 external AI key required. By stripping out those external dependencies, this entire build becomes completely reproducible and drastically reduces the risk of failure during judging. QStorm Investigator is fast, exact, and above all, safe, which leaves us with a really provocative question to wrap up on. Is deterministic evidence reasoning ultimately superior to fragile model output when it comes to actual production systems? It definitely makes you rethink whether throwing an LLM at a problem is always the smartest move. Anyway, that is definitely something to chew on for your next safety-first build. Thanks so much for joining us for this explainer, and we'll catch you next time.